Okay, so we left off here on Friday, and you know, we tried these problems, and some of them went well, some of them didn't go quite as well. But we're going to continue to practice today, and we're going to practice with letter P, which says sine squared of theta times secant squared of theta minus sine squared of theta. So you could write this as sine and cosine, so you could convert secant squared to 1 over cosine squared. That won't get you very far, so you could go ahead and try that path. It's not going to work out very well. What I like to do, what I see in this situation, is that they both have a common factor, and that's going to help me out. What do they both share in common? They both have a sine squared. So I'm going to take out that sine squared of theta. And when I do, what am I left with? Secant squared of theta minus 1. That's good news, because anytime you got a squared and then a plus or minus 1, there's a good chance that it fits a trigonometric identity that we might like to use. So, boy, I don't know where they all went. Here they are. If you look here, we have secant squared minus 1, right? That's equal to what? Tangent squared. Now, again, I give this stuff to you guys on the test, but that does not guarantee that you're going to remember where to necessarily find it. So as soon as I see a 1 and a secant squared, I go to this number 6 right here, and I try to toggle through this and see what I can find. So secant squared minus 1 equals tangent squared of theta is what I'm going to use right now. So let's go there. There we go. Whoop, one more. So here I'm going to write sine squared of theta times tangent squared of theta. Okay, so I reduce that somewhat. What would you do next? Come on. Yeah. Yeah, change tangent, sine, and cosine. You get sine squared of theta times sine squared of theta over cosine squared of theta, right? Does anything cancel? No. We actually kind of make things worse if we do that, don't we? So we would say that this is the most simplified. Unfortunately, it does not reduce any further than that. Sine to the 4th over cosine squared is not any more helpful to us at all. So we're going to stop with sine squared times tangent squared. I'm going to let you do Q on your own right now and practice that. What is the common factor you could take out of Q? Cosine squared. Go ahead and try that. Okay, I'll go through the problem. Looks like most people got it. You could take out a cosine squared of theta right away, and you're left with 1 plus tangent squared of theta. Any questions how I got that? Then if you look at your sheet, number 6 says that 1 plus tangent squared of theta is secant squared of theta. Well, what's the relationship between cosine and secant? They're inverses. And if you multiply 2 inverses, you get 1. So I have cosine squared of theta over 1 times 1 over cosine squared of theta. And I get 1. What's that? Secant squared is represented as 1 over cosine squared. So, okay, so 1 over secant squared times secant squared is, but either way it's still 1. Yep, that will be fine as well. Okay, now I hate to say that, but those were the easier set of problems that you would see on the test. Okay, so now we're going to venture into some that are what I refer to as slightly more difficult. And in the end, you just kind of got to jump in and try them, and hopefully it works out for you. and learn and come in and ask questions and check your answer books and all those good things. But don't be afraid to allow this to take a little while to learn. So let's look at this first one. This was hard for some people. Hopefully it won't be for you guys. But I see tangent squared over secant of theta minus 1. Now, why is this unique compared to the other problems that we've done? Secant is not squared. As a matter of fact, Parker said right away, he said, Mr. Gentz, didn't you make a mistake? You didn't write a squared on the bottom. Had I written a squared, that problem would be significantly easier, but there's no squared. And so I got to do something else. And this is going to seem counterintuitive, but here's what I'm going to do. I'm going to take this tangent squared, and I know from my formula sheet that tangent squared is actually equal to something else. If I look at number 6 right here, it says that tangent squared is equal to secant squared minus 1. So I'm going to substitute that in, and then you'll see why I would do something like that. So I'm going to rewrite this as secant squared of theta minus 1 over secant of theta minus 1. So all I did is instead of writing tangent squared, I wrote secant squared. Now, the formula says tangent squared is equal to secant squared minus 1. So I could plug that in. Now here's something else. Secant squared minus 1, true or false? That factors. It's the difference of two squares, so it does factor. In fact, I show you right here that it factors to secant of theta minus 1 times secant of theta plus 1. So it factors. So I'm going to take that piece that I just wrote down, and I'm going to factor it. So I'm going to write it as secant of theta minus 1 times secant of theta plus 1. All divided by secant of theta minus 1. Now, I do have two expressions that will cancel. But note that you have to write it in this factored form in order to do that. Question, Jalen. Nope, because Miss Nelson will cut your fingers off when you do that. That's like saying this. So for everybody that wants to do that, that's like, here's what you're doing. You're doing 16 minus 2 over 4 plus 2 or something like that, okay? And you want to say, well, I could just cross off the 2's, and 16 divided by 4 is 4. That's not the mathematics that we can do, right? We would all agree that that is incorrect. So as soon as you get tempted to do something, just write yourself a few numbers on the board and start crossing some stuff off. And then your fingers will start to hurt, and you'll realize that's a no-no. I have to factor it. In order to cross stuff off, you have to write as multiplication. I do have two pieces written as multiplication. The secant of theta minus 1 and the secant of theta minus 1 cross off. I'm left with secant of theta plus 1. That's what that reduces to. So that's new. Okay, you haven't seen that trick before, so to speak. So I've showed you, switching between sine and cosine. I've showed you to distribute. I've showed you to factor. I've now showed you where you substitute something longer into factor. And so hopefully these are starting to reference. But these are some of the tricks of the trade you're going to have to pull from. So let's now try H on the other side. And I'm going to let you work through a few for a while. And some of you will have success. Some of you will get frustrated. It's okay. We'll come back together. We'll go through a few more. And we'll kind of redeem our learning here. But if this is not easy for you, you're normal. If this is easy for you, then you're a little bit abnormal. Okay? And that's you're okay either way. All right? So H, it says cosine of theta times tangent of theta plus cotangent of theta times cosine of theta. Now, this has nothing squared, does it? And I don't see anything I can immediately substitute in, so I guess what I would like to do right away is convert everything to sine and cosine. Can we do that? Yes, good point. You could take out a cosine of theta right away, and after you do, you'll realize that that doesn't help you. So Samantha Stanley is absolutely correct. Take out a cosine of theta, but when you do, you'll be left with nothing that is helpful. Okay. So I happen to know how the problem works out, so we'll try this. We'll go cosine of theta over 1 times tangent of theta is sine of theta over cosine of theta. Plus cotangent of theta is cosine of theta over sine of theta times cosine of theta over 1. Okay, so what happens, Alex? Those cosines will cancel, and you'll be left with this expression, sine of theta. I'm going to write it over 1. Two cosines. What are there two problems? Okay. So I got sine of theta over 1 plus cosine squared of theta over sine of theta. This actually looks kind of interesting. I don't see anything that helps me yet, but maybe soon I will. Parker, you see something you want to do? Good idea. We're going to do that. We're going to find common denominators here. Multiply the tops and bottom by sine of theta. So what I did is I multiplied the top and bottom here by sine of theta. I got sine squared of theta over sine of theta plus cosine squared of theta over sine of theta. Oh boy. You don't see it yet. What they have common denominators now, right? So I have sine squared of theta plus cosine squared of theta all over sine of theta. Come on. Sine squared plus cosine squared is 1. That's our most important one. One over sine of theta, which is cosecant. Isn't that beautiful? If you're intrigued by anything, you should be intrigued by the relationships, how connected they all are, how they reduce. This is why you worked with complex fractions last year in Algebra 2. And we're going to continue to work through these things. You go ahead, and I would urge you to start right here with problem B, C, and D. And, you know, they don't all work out the same, okay? You just give them a shot, see where you get. And we'll come back, and we'll do a few more on the board here in a little bit. Let's look at D first, since that's the one that a lot of people are getting confused by. I'm going to write it all out in lawn terms so that everybody can see it. But most people would do this in a little bit shortened fashion. So watch what I'm going to do here, okay? I'm going to write this as follows. Sine of theta times sine of theta plus 1 over sine of theta times cosine squared of theta. Now, here's what people are doing is they're distributing it. How many times do you need to distribute this? Just twice. Some people want to distribute it 3 times. Once to the sine, once to the 1 over sine, and once to the cosine squared. You don't, okay? You distribute multiplication over addition and subtraction. If I gave you guys this, if I said 2 times 3 times 4, would you take 2 times the 3 and the 2 times the 4? No, you would take 2 times 3 is 6, times 4 is 24. That's what you would do. So that's all we're doing in this scenario. What's sine times sine? Sine squared. Plus, what's sine of theta times 1 over sine of theta? 1. So you're left with 1 times cosine squared. Right? I don't need to take sine times cosine squared. That's already multiplied in the 1 over sine. I'll write it out one more time. So now I did distribute it to the two pieces, and you can see that this goes away. You're left with sine squared plus cosine squared. And number 5 on your formula sheet says sine squared plus cosine squared is 1. Let's look at B. What did you substitute in for B right away? You should have substituted 1 minus cosine squared of theta in for sine squared. And when you do that, the bottom factors, you get cosine of theta plus 1 divided by 1 minus cosine of theta times 1 plus cosine of theta. And the cosine of thetas plus 1 cancel, and you should be left with 1 over 1 minus cosine of theta. That cannot be simplified further. In C, do you see anything squared in problem C? No, nothing squared. But if I distribute, will I get something squared? Secant times secant is secant squared of theta. Minus, what is the relationship between secant and cosine? They're reciprocals, and if you multiply reciprocals, that's an inverse operation. You get 1. Secant squared of theta minus 1 on your formula sheet is tangent squared of theta. We'll do one more together, and I want to let you guys be on your own. F says tangent of theta plus secant of theta times tangent of theta minus secant of theta. What do you notice about those two expressions? They are conjugates. Conjugates are where you have a plus in one and a minus in the other. And those are nice because if you multiply two conjugates, the middles will cancel. Watch. What's tangent times tangent? Tangent squared of theta. What's tangent times negative secant? Negative secant of theta, tangent of theta. What's secant times tangent? Secant of theta times tangent of theta. Minus secant times secant is secant squared. What do you notice about the middles? They cancel. When you multiply two things together that are conjugates, the middles cancel. And again, that's not trigonometry. That's algebra. Right? This is like 2 plus x times 2 minus x. And when you see that, you should say, oh, that's great, because then I'll end up with 4 minus x squared. You know that right away. Same type of process here. Secant of theta and tangent of theta, those go away. You're left with tangent squared minus secant squared. Now, I know that there's a relationship between tangent squared and secant squared. Do you see that exact expression on your sheet? Nope, not that exact expression. I do know that tangent squared of theta is equal to secant squared of theta minus 1. And then we'll minus secant squared of theta off of that. What happens? Those cancel. Left with -1. Question, Whitney. You could do sine squared of theta over cosine squared of theta. I don't know if that's going to get you anywhere. So good. So Sam, you tried one, right? And it didn't help out, right? You guys, I'm doing all these. Should I start doing them where they don't work out the first time? That might confuse you more, right? So understand, you guys, that I've been doing these for many years. I've seen most every example, and I know where they're going. You're not going to have necessarily that success right away. If you do, good for you. That's great. But don't be afraid to try it and not get a right result and then have to try a different avenue. That's okay. What I want you to do is I want you to continue to work on these. You have a few left to try on your own, and this is your assignment. It's so important that you practice this assignment right here. You have some basic problems, and you have some harder problems. On your test, this will be a section on your test. And the fact of the matter is I believe that this will be, for most people, the harder part of their test. I don't know. I guess we'll have to see where the rest ends up. But tomorrow, I want to move on to verifying these identities as they are set equal to each other. So please work on this tonight. This would be very good for you to do. So we did most of your first worksheet with you in class. Let that serve as notes, but that's one assignment. Here's another assignment. Make sure that you give this some attention right away so you don't forget how to do it. I will sign out. Goodbye, YouTube world.